a video from section 2, which is the basic concept of vectors, and this video in particular is going to be two fundamental ideas. So there are a few ideas regarding vectors which we need to be aware of. One of these is that two vectors are equal when they have the same magnitude and direction. And where they are in space is completely irrelevant, and this is going to make sense in a second. So think, for example, a Mercedes travelling at 60 miles an hour north within London. Well, this is going to be the exact same vector quantity as an Astra travelling also at 60 miles an hour north, however, in Manchester. In this short extract of information, we've got two cars. Completely irrelevant, doesn't matter. But what's important is the magnitude of them both, which is 60 miles per hour, and also the direction, which is north and north. So the vector quantity, we should know a vector now, is made up of a magnitude and a direction. And for these two vehicles, the magnitude and direction is exactly the same. However, what's different is the type of vehicle, does not matter in the slightest, and also the area or region within space, because one is in London or within London and one is in Manchester. So where they are in space is different. Next then, we have two vectors which are opposite, and they're opposite when they have equal magnitudes but are in opposite directions to one another. So I've not wrote an example here because it's fairly self-explanatory, and I will highlight this, not underline it. But basically, think about the exact same example from above. Say, for example, we had a Mercedes travelling at 60 miles an hour north within London, yet again. But now imagine that the Astra was travelling 60 miles an hour south in Manchester. Everything's the same except from the direction for the second vehicle. And because the two vehicles are now travelling in opposite directions, that means that the two vectors are opposite to one another. So a final little bit of information for this is that the above vectors are known as free vectors. I kind of emphasize the fact that where they are in space doesn't matter, and that's because for free vectors they can be anywhere in space, yet all we pay attention to is the magnitude and direction. Later on we'll come across position vectors which do matter where they are in space, but for now that's unimportant. And for the above vectors, as we now know that they're known as free vectors, the reason they're known as free vectors, I'll reiterate, is because where they are in space is irrelevant. So I hope that makes sense, and yeah, that's it for 2.2, which is two fundamental ideas.